Hello and welcome to our today's webcast. My name is Denis Zyk and I'm working at Oxylabs as Golang Developer. Today, we will also have a very special guest, Fabien. Say hello, Fabien.
Hi, Denis. Thank you very much. So my name is Fabien Vauchelles. I've been passionate about web scraping and anti-bot system for years. I work at Wiremind as an anti-bot expert. At Wiremind, we specialize in revenue management, where we collect millions of prices every day. Our setup for data collection is pretty big, many built on open source. I'm also the creator of Scripoxy. Scripoxy is a free and open source proxy waterfall. It allows you to manage and route traffic like cloud provider and proxy services. It supports major cloud providers such as AWS, Azure, GCP, DigitalOcean. But let's go to our topic. So when we collect data, we are often blocked by anti-bot systems. We try to find tricks, tools, and library to get around them. But it's not just about adding tools blindly. It is crucial to understand how they catch us. So we need to understand how anti-bot system assess us. So they meticulously check our browser stack, analyzing each signals. Starting with our IP address, they know where we are coming from. The protocol header divulges details about our operating system, the browser, the versions, and they execute JavaScript to get system and browser configurations. Also, they track navigation patterns like the sequence of web pages and even the sequence of events such as mouse movements. And they cross-reference all these signals to validate consistency. So let's dive into each layer of the browser stack. The initial layer is the IP address layers. It is the very first piece of information a website obtains when we establish connections. And an IP address is a goldmine of informations. Are we connecting from an internet box? Are we connecting from a mobile phone? Are we connecting from data centers? For instance, if we are purchasing a flight ticket from Paris to New York, is our connection originating from India? Is there any inconsistency, such as using a US IP address while a browser time zone setting is in Europe? All those flags can trigger you. Moving on to the second layer, let's understand the power of protocol headers. In this part, we can distinguish three protocols: TCP, TLS, and HTTP2. First up is the TCP protocols. The RFC describes how operating systems should implement the TCP protocol. But in practice, the implementation often varies not only from one operating system to another, but even between the different versions of the same operating systems. And by examining the TCP headers, it is possible to statistically deduce which operating system is responsible for sending the packets. Second up is the Transport Layer Security Protocol, the TLS protocol. This protocol is used everywhere. It's an encryption protocol on top of the TCP protocol. So here is an overview of how it works. So when a browser creates a secure connection, it initiates negotiations with a website. This negotiation is called the handshake protocols. During this process, the browser sends a client hello message. And this message includes a list of supported encryption algorithms such as RSA, DSA, and also some options. It is called the cipher suite. The server selects the most secure and compatible algorithm from the list, and they initiate a key exchange to secure the connections. This is where the magic unfolds. Each browser version has its unique cipher suite and options. This leads to the creation of a TLS fingerprint called the JS3 fingerprints. It was invented by Salesforce. With this fingerprint, the server can identify which library your browser is. Is it Chrome? Is it Firefox? Is it Edge? Is it a Go library? Is it a Python library? Is it a Node.js library? So we can detect who is sending packets and is it automations. Third up is the HTTP2 protocols. HTTP2 headers listen to TCP headers. Browser implementations introduce variations on settings, priority flags, field order, etc. And by examining each HTTP2 header, it is possible to statistically deduce which browser is responsible for sending the packets. Also, if we look at the HTTP protocol, we can fingerprint the HTTP headers. Here is a small code of a well-known antibot system for Node.js server. The code is public on the internet. It is just 4 lines of code, but it's bulletproof. These tiny little functions get the list and order of headers. Because when we develop a scraper, we often try to reduce the number of headers to the bare minimums. We strip away as many headers as possible to create a simple and maintainable payload. However, when you read these functions, you realize that all headers are crucial. Even if they are not essential for the API, they are vital for the fingerprint process. And this function can block most of the scraper. Of course, also, all browsers can execute JavaScript. It is truly astonishing how much information antibot system can extract from JavaScript. They can get detail like our time zone, the GPU model, the GPU fingerprint to be checked with the GPU models, also the number of speakers, the model of speakers, the microphone status, the webcam, the battery level, so they know if we are using a smartphone or a laptop, the list of front install, the list of plugin or browser extensions, the adblock setting, if we are disclosing the real IP address with the WebRTC leak, the screen site, etc. And if you are using Android, there is also a lot of information disclosed. They can know if you are using Android debug, so if you are doing some reverse engineering process. They can know the device architectures. Do you use ARM or Intel architectures? Because most of emulator use Intel architectures and device use ARMs. They can get also the Android versions, the smartphone models, and one very specific ID, which is the Android installation ID. It is a unique ID created at the installation of Android, so they can track you everywhere. And it's not finished. They can know also how we act on the website. Antibot system observes the sequence of web pages we visit. Do we initiate our journey with a search query, or do we access data with a specific deep link? Are we executing JavaScript and loading CSS, or are we only loading HTMLs? Furthermore, they track the timing of our actions, the interval between web pages, the delay between mouse clicks. They also check mouse movements. Humans tend to move the mouse cursor in a natural, fluid manner, often resembling to a basic curve, as opposed to a straight line movements. All this information are transmitted to the web server at interval. That's why sometimes we navigate smoothly a website, successfully completing several requests, and suddenly you get a captcha. This happens because our reputation score gradually reduces over time and go through a threshold. So the antibot push you a captcha or perhaps directly block you. And all these signals are combined together to generate binary classification scores. Algorithms blend everything and use machine learning technique to rate the browser sessions. And to improve and adapt over time, they can use reinforcement algorithms like CatBoost. Now, let me share with you a standard antibot architecture. So it's a 3-step dance. There is the browser, the website, and the antibot. So when we connect to a website, our browser also connects to an antibot URL. Sometimes this URL can be hosted on the website, sometimes it's on the separated server. So with JavaScript, the website gathers a lot of data about a browser, device like configurations, even mouse movements, etc. The payload is encrypted and sent to the antibot URL. In return, the antibot system issues a cookie that is linked to our sessions. This process is repeated at regular intervals to monitor the sessions. Now, when we access the website, not the antibot URL, we send this cookie along with a request. And the website initiates a server-to-server request to the antibot system to retrieve a reputation score. And based on this score, the website makes a decision to either grant or deny those access. As we saw, it is difficult to handle antibot system. So we need a methodology for constructing a scraper, because websites and protections quickly evolve. Additionally, it is important to note that not all websites are equally protected. Some websites have no protection, some websites have minimal protections, some websites have hard protections. And using the same approach for every website can be costly and time-consuming. So we need an incremental methodology to adjust our strategy. So imagine that you already have a scraper. You perhaps use Scrapy, the famous Python framework for web scraping. So we can use this possible methodology, which is a generate methodology. So if it's not working, perhaps it's time to tune the parameters. We can adjust the delay between requests, the number of concurrent requests, the HTTP headers, make it consistent. We can set if we use cookie or not, change the TLS versions, adjust the payload and the order of requests. If it's not working, it's perhaps we are doing all the requests from the same IP address, the same server. So we need to introduce the concept of proxy. So what is a proxy? A proxy is a system which relays a request to a server. So instead of seeing one server sending millions of requests, the website will see a lot of customers sending a small amount of requests. And there is a lot of type of proxy, but we can start with data center proxy. They are fast, cheap, and reliable. We can also plug Scraproxy to correctly orchestrate the proxy strategy. If it's not working, it's perhaps we are not acting like a browser. So we need to introduce headless browsers. So there is a lot of framework for headless browser. There is Puppeteer, Playwright, Selenium, and there is a lot of extension to skip the JavaScript fingerprint to do that, like the Still plugin, the Ghost cursor to move the mouse in a natural, fluid manner, like a basic curve. And now, if it's not working, it's perhaps we are using only data center proxy. So we need to introduce other type of proxy. So there is many type of proxy like ISP proxy, residential proxy, mobile proxy, hardware proxy. So what is ISP proxy? ISP proxy is like data center proxy, but they don't use the IP address from the data center. They use IP address which are rent from mobile provider, carrier provider, internet provider. So the IP range is mixed between real IP address. Also, there is residential proxy. So what is residential proxy? It's when users share their bandwidth for money. So you can do that, download an app to share your bandwidth and get some money. And we use this IP address. It is residential proxy. Also, there is some provider providing 4G keys, so it's mobile providers, but you can do yourself the 4G key management and have the hardware at home. It's called hardware proxy. So we can use this kind of proxy. And now if it's not working, it's perhaps because automation is detected. Because yes, if we are looking to Puppeteer, Playwright, or this kind of framework, they are leaving in the code some flag. So the antibot love to check this flag and detect the framework. So perhaps we need to introduce the concept of headful browser to create our own browser inside the Docker. To do that, there is commercial solutions, but you can use open source library to do. And if everything is not working, perhaps you can try the Web Unblocker API. So what is Unblocker API? It is the Unblocker API will do all the previous steps for you. It is a commercial solution, but it is very effective, and you can directly jump to this step. And I think Denis has some information to share about that.
Yeah, thank you, Fabien. Thank you very much for great and insightful overview on the blocking techniques and avoiding all the difficulties and all the cumbersome steps which are introduced by anti-bot systems, coupled with beautiful visuals. I really enjoyed your slides. Thank you. And yeah, what's regarding Web Unblocker? Web Unblocker, it's a proprietary AI-powered proxy solution developed at Oxylabs, which leverages machine learning proxy pool management. It also incorporates dynamic browser fingerprinting and response recognition system to unblock even the most difficult sites. So the thing here is that you can use Web Unblocker instead of self-managed proxies, because you will only be invoiced for successful results, while at self-managed classic proxies, you will have to pay for all the traffic you send through the proxies. At the same time, Web Unblocker offers auto-retry, capture, bypass, various fingerprinting techniques, dynamic scraping strategy, discovery, and so on and so forth. And what's more important, it eliminates all the hassle of managing all those things which are important to avoid being blocked, which have just were mentioned by Fabien. So instead of having to think and wrap your hand around all those things and try to update them and maintain, you can just give a try to Web Unblocker, where we solve all those issues for you already. So how does Web Unblocker work? Actually, it integrates as a proxy endpoint solution. So you just kind of relay your request to the target to this Web Unblocker proxy, which then tries to detect the type of the target, tries to detect the response, whether the response was good or bad, whether the target request has been blocked or not, and what to do to avoid getting blocked. Finally, until it reaches and receives the valid, perfectly good response, which is then returned back to the customer. To spice up the things a little bit more, we have some really nice features available in Web Unblocker, where you can tune in your requests even more, not just scrape the data from the target as if you've been doing it with regular proxies. And one of those features is browser instructions. It's this kind of feature where you can pass some custom instructions, and those instructions will be executed in a real browser, as if those instructions were performed by a puppeteer or by a real person. For example, clicking into forms, typing stuff, clicking on the buttons, scrolling page, and so on. All this is available via browser instructions. Another thing to note is that you can actually specify and pass your own custom cookies or even headers. Because the way Web Unblocker works, it selects and predefines a set of headers or cookies which are known to be working best with this specific target to avoid getting blocked. And in case you really need to override some of those headers or cookies, you can specify these parameters to be able to pass your own values. And here to demonstration. Okay, so here we have a regular Postman application instance. So as a check, here we have no Web Unblocker proxy configured so far. So as we can see, there is nothing here. And let's try to make a test request to ipinfo.io/headers. So here we can see that our current location is Lithuania. And if we do several more requests, the data stays roughly the same. So here we will enable our proxy solution, Web Unblocker. Here we have webunblock.oxylabs.io, port 60,000. So if we try to do another request via our Web Unblocker, we can see that the IP address has already changed, as well as our location being detected as United States. Let's try to pass some custom cookies. So if we, for example, have Oxylabs force cookies set as 0, so we're instructing Web Unblocker to actually ignore all the cookies which we are passing. And here we can add some cookies to our domain. Let's say we don't need any expiration date, and there is my test cookie equals webcast. Right, let's save it. And if we try to pass that cookie, we can see that there are no cookies passed whatsoever, even though we've specified the cookies. So if we change this parameter to 1, saying that we want to force our provided cookies to be used with the request to the target by Web Unblocker, and do another request with this parameter set as 1, we can see that here our custom cookies being passed. Another thing with Web Unblocker is browser instructions. So here I will show you example of ebay.com. So for example, if we request ebay.com, we can see there is this homepage with all the stuff, just the homepage. And let's say we want to enter some custom query, let's say sunglasses 2024 into this search bar, and then click search to actually, we want browser to do some actions on our site for us. And we are asking it to input sunglasses 2024 into search bar, and then doing the search for us and waiting for 5 seconds to actually for result to load. And if we do this request now, yep. And here we can see that actually the result which was returned by Web Unblocker, this search page with sunglasses 2024 being entered already, even though we were asking for the homepage. So actually what was done behind the scenes is Web Unblocker taking the target website and then firing it up, loading it up in the real browser, and actually performing the instructions provided, which is entering sunglasses 2024 in the search field, clicking search, and waiting for the search results to be loaded. Yeah, and that was our Web Unblocker demo. I hope you enjoyed it. Yeah, and as anti-bot systems becoming more advanced and sophisticated, we need to find new ways to gather publicly available data because every day we are facing more and more challenges to do so. However, certain techniques and tools could be used to devise scraping strategy. Web Unblocker is very nice tool, I would say, or product. It depends how you're using it, how you're perceiving the Web Unblocker. It really plays vital role in gathering public data because it covers more than one solution and it combines everything in one place. So you don't need to think and face all those challenges yourself. All those things like headers, session management, proxy, IP pools, and blah, 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 yada, yada, all these things are already covered by Web Unblocker. And we have some most frequently asked questions prepared from our users, from our clients, and from scripting community, which we support at our Discord channel. And let's try to have a look at those questions and try to answer them. The first one is, are there any emerging technologies or trends that are shaping the future of anti-bot systems and web scraping? Yeah, well, there are. I know there are some emerging technologies like doing more requests using residential IP addresses or proxies, but on this other side, those the IP traffic is more expensive in that way. So we're trying to find to balance this out. What are your thoughts on this question, Fabien?
Yeah, that's a very good question. And as you say, there is a lot of residential proxy moving today. I'm seeing three trends in anti-bot system in web scraping industry in 2024. First, I think there is a big focus on making anti-bot measure more consistent, going beyond just checking user agent, For example, TLS fingerprint is being used to figure out what browser and operating system you're using. This means that Linux user might have more trouble accessing some website because they are being flagged by anti-bot systems. Second, I think there is a rise in techniques, in fingerprinting techniques. Before, it was most about checking setting, getting the configurations, through JavaScript executions. But now anti-bot systems are looking for more complex fingerprint like graphic fingerprint to see if you are a real GPU, not just checking the model with JavaScript, but doing real drawings on a canvas, which is hidden, so they can get a real fingerprint of that. Also, we see some companies that introducing new obfuscation layers on top of the existing obfuscation. It's like a JavaScript virtual machine. It's a kind to Java virtual machine, but this time in JavaScript. But the bytecode is proprietary, so it's very, very challenging to transition from the bytecode to actual source code, and it's very difficult to know which signals they are monitoring. And as you discuss about residential, I know for sure there is ongoing explorations in the detection of residential IP address, but clearly it's still in research phase. But this is something that we will see more prevalent into the futures.
All right. Yeah. Thank you very much. That's really making the trend into 2024, I would say. The next one is, what are some creative ways to mimic human behavior and evade detection by anti-bot systems? So I guess this question plays nicely with the previous one, with those trends. And then what are the techniques to actually catch up with those trends?
Yes, you're totally right. The thing is, it's very difficult now to bypass anti-bot system. So the first thing is the consistency. The consistency is the key. It is the best way to avoid triggering anti-bot measures. It is always good to invest time in understanding how users typically interact with a website to aim to mimic their behaviors. Moreover, your approach will vary depending on the website. Some websites spot data center IP addresses, so we need residential IP addresses. Some websites execute JavaScript, so we need headless browsers. Some websites look for automation, so we need custom headless browser, etc., etc. Also, one advice is to seek on Windows or act like you're on Windows operating systems. Now, running a headless browser in a Docker, which typically use Linux, doesn't work anymore. So we need to emulate or to run a real virtual machine on Windows.
Okay, so it's now back to Windows era, you may say.
Unfortunately, yes.
Okay. Yeah, the next question is, can you integrate Web Unblocker with an existing code? This one is on me, I'd say. You can definitely integrate Web Unblocker with your existing code. Moreover, if you were already using some HTTP or HTTPS proxies, this way you can integrate Web Unblocker because it integrates as a proxy endpoint. You just specify a Web Unblocker and its credentials and your user credentials for Web Unblocker product as a proxy within your code, and just fire up those requests as if it was a simple generic relay proxy. So there are numerous code examples on our web documentation online. We are covering those examples are covering such programming languages as Java, Node.js, PHP, Golang, Python. So you are welcome to go and have a look around. Are there any open source tools or libraries available to help test and circumvent anti-bot systems in a controlled environment? Well, I guess there are. I don't personally do that on a day-to-day basis, I'd say. But what is your opinion on this one?
Yes, it's a very good question. There are plenty of open source tools. But as you said previously, using open source tools take time and expertise for setup and maintenance. So let me share with you some open source tools. For handling multiple proxy providers, you can use Proxy. It is very helpful. It is a proxy waterfall that can handle all your provider and IP pools. When it comes to scraping, Scrapy is the well-known Python framework. It supports many plugins such as Scriptproxy and even plugins like Scrapy Impersonate for changing the TLS fingerprint. Additionally, you can combine Playwright with Scrapy to have a headless browsers. Integrating Playwright to Scrapy is very straightforward. It's very easy to do that. However, we get back to the presentations. You might be detected because Playwright is easily detectable by anti-bot system. So it depends what amount of time you want to invest in the open source solutions and the maintenance.
Yeah, it depends. Everything depends on the use case. If it's really feasible to do your own research in that matter, or if it's cheaper just to go and stick to already working solution online available on the market. Yeah, those were all questions we had for today. Thank you very much, Fabien, for your presentation. Thank you, everyone, for listening and watching us. Please join us on Discord. Keep the discussions going, and see you next time on the next webcast.
Thank you very much.
Bye-bye.
Bye-bye.